Hello and welcome to our ME1222 Energy Harvester presentation by Sean Stephenson and Braden Augustus. We will be going over our design challenge number 2, which was an energy harvesting device. Energy harvesting device would be something that could be built before December 2024, and the system should harvest mechanical energy while also surviving for 1 week inside of Patrick F. Taylor Hall. The metrics of success included that the system should capture energy from available sources. The system and method of energy capture are useful, and the system and method of energy capture should be interesting and demonstrate creativity for the ideation phase. So the three concepts we came up with was one being a water fountain paddle wheel, which every time the water fountain was used, it would spin, which we converted to shaft work. Next concept that we came up with, which is our current design, would be the water wheel, which every time somebody spins the water wheel, the water inside of the water bottles that were connected to the wheel would use the weight of gravity to keep the wheel spinning for an immense amount of time after the wheel was initially spun, using the mechanical energy that somebody put into the wheel, allowing it to transfer and keep spinning. Third design would have been a door counter, which every time somebody opened the door, it would count it due to the energy that's being put into the door and coming out, allowing for the door counter to work to, let's say, you can count how many times the door is open per class period or per any time somebody opened the door in that certain area. Many designs, so many beautiful, amazing designs. One could possibly think, how do we choose between all of these amazing designs? Well, I got something for you. The house of quality is where it's at.
In constructing our house of quality, it began with the what's, which are the main deliverables for our energy harvester. That being that it's quickly built, that it harvests mechanical energy, that it can survive in PFT for a week, that it captures unused, useful energy, and also that it's interesting. And then after that, we weighed them based on their importance to our project, with 1 being the least important and 6 being the most. After that, moving into the hows on how we could deliver the deliverables. Those are the durability, the simplicity, the weight, the appeal to the eye, the placement and installation, and then ease of use. And then the matrix between the what's and the hows is comparing exactly how the hows impact the what's based on their importance. And then moving from there, the cone at the top weighs the hows against each other on how they benefit each other hand in tandem. Moving to the bottom, we weighed out the importance of each how based on purely the weight of the whole project on the importance of the what's, getting a raw score of which how is more important. After that, we found the average and then put the importance weight into 100 to find their relative importance weight out of 100%. And then finally, to wrap up the design, the far right matrix weighs out each design compared to the what's and the hows to find out which one is more beneficial for each category.
Based upon that beautiful house of quality presented by Braden Augustus, it was time to finally make a decision. And our decision would be to go with the water wheel, as we felt the water wheel was the most efficient based off of the house of quality. The water wheel exhibited unused energy put into the wheel and an output of mechanical energy based on the energy that was put into the wheel. So in this image, we can see that there's 6 water bottles that are zip tied to the wheel. Once the wheel is spun, the water inside of each water bottle would continue the motion of the wheel for a prolonged period of time. This was our original concept and our first iteration of our concept. But then we started to run into some issues while doing initial testing that prompted us to find solutions for them. Some of the issues that became roadblocks were that the water bottles that were used were too big. The water bottles started to knock against the base. We tied each bottle with one zip tie around its body, resulting in loosely tied bottles due to the evaporation of the water inside of the water bottles. And finally, we did not actually measure how much salt water that we poured into each bottle. So when spun, Some of the water bottles with more water would slow the wheel down so much that it would eventually come to a stop, which we wanted a prolonged spinning motion from the wheel. We then found solutions to these problems, and that's how we came up with our iteration number 2.
Moving forward, we decided to use shorter but fatter water bottles to be able to make up for the space but carry the same weight. And we used 2 zip ties rather than 1 to have them more rigid, and we tied around the neck so the weight could be distributed more evenly. Finally, we used a measuring weight and a scale to weigh out the saltwater solution, which the bottles look different here, but it was just purple dye and salt water in each to even out the weight and make sure that it would be able to flow smoother.
Wow, thank you, Braden. That was absolutely beautiful. But another thing I would like to point out is the fact that at the bottom on the base, there is a square cutout. And that was because every time the water bottles would start hitting at the bottom because they were starting to get loose from the zip ties. So we implemented that hole there just so the water bottles couldn't rub and it wouldn't slow down the wheel any further.
Once we decided on the saltwater wheel concept, we ran into a problem. No one would want to just walk up to a wheel with a bunch of bottles on it and spin it. And then the less people that spin it would lead to less energy harvested, which would allow us to fail on some of the deliverables. So we decided on some modifications that could add some appeal to the saltwater wheel. And the goal in this was to promote the intrigue in the audience to gain more spins to harvest more energy to give more practical use. The 3 concepts that we went over were a prize wheel concept, which was each bottle would have a different prize, and so you spin it, and whatever the prize was, you would receive. The magic 8-ball concept, which each bottle would have a brand solution such as yes, no, click, spin again, things of that nature, or the lottery concept, something on the lines of the 25th person that spins gets a Panera gift card, or just anything in the sense of gambling, as in you put in with a chance to get out. And after weighing the 3, we decided that Magic 8 Ball was cheaper because we didn't have to give anyone anything, and could also be physically much more appealing to the eye than the other 2 concepts.
Here you can see this is our final design. Right here we have a poster board on the outside of the whole wheel, which says spin here. In the middle, we have a little bit of product placement with the Magic 8 Ball. We have the little 8 in the middle, and then we have a slit that says answer. Now, on each water bottle, there's 6 different answers, so it's basically randomized that when the user spins the wheel, he can get one of the 6 answers. We decided to go with this final design because we felt that the other designs were too inexpensive and we didn't want to keep having to buy prizes for each person that would win a prize, as it would start to generate more money, and that would basically contradict the option of feasibility for our design. So this is our final design. It's very stylistic, and the writing, of course, was done by me.
Now, as you can see, I just presented you with a video of how the wheel functioned. Basically, whenever the wheel was spun, I didn't spin it with that much force. That's the reason why it didn't spin for too long. But after the wheel was spun for about 20-30 seconds, it continued to teeter back and forth, giving you the desired answer, or maybe not desired answer, that the user was looking for. After choosing a design of which concept we would go at, we chose the saltwater wheel. After doing so, we created a bill of materials, the bike wheel being $39.99, the zip ties and a 40-count bag being $3.99, salt in a 26-ounce container being $1.69, purple dye being $2.99, and water bottles being $6.99. The water bottles is actually a 6-pack of essential water. With these materials, you can construct the same wheel that we constructed.
After the wheel was manufactured and the final touches were put on it, we decided that it was time to take it into Patrick Taylor Hall and record the results. On top of the results of getting interactions, we made a QR code available for users to be able to report their use and if they would use it again. The survey asked 3 questions. Have you ever used the Magic 8 Ball? Did you enjoy using the wheel? And would you use it again? And then what guided you to spin the wheel? After leaving out in Patrick Taylor Hall for a few hours, we got 18 responses. Most people said that they did enjoy using the wheel, based on the scale of 1 to 10, with most people saying 10. When asked if they would use the wheel again, 77.8% of people said that they would, opposed to 22.2% who said they wouldn't. And then the appeal of the recognizability of the brand for have you ever used the Magic 8 Ball, 94.4% of users said they had.
As a bonus, I'm going to incorporate our idea of how we could harvest energy if we weren't on a budget. So our group had the idea that we would hook up a belt that was connected to a generator onto the other end of the wheel, which the opposite side of which the user is spinning. Once the wheel is spun, the belt would then spin along with the wheel, and the spinning of the belt would be connected to a wheel on the generator, allowing for energy to be harvested. This energy could be turned into electrical energy and used to charge phones, charge computers, charge anything that could use electricity, basically. And essentially, this would be a fun little idea that if you get bored and you just so happen to need to charge something, that you could use our wheel, interact with it, and also get a positive outcome from the wheel. I just thought that was a little neat idea to add on to the presentation.
This is time for my final feedback of the project. Basically, this was an amazing project. I had an amazing team with Michael Dunlap, Jonah Anderson, Braden Augustus, and me, Sean Stephenson. And I really appreciated how we worked together as a team. We all had different parts of the design process that we were responsible for. And overall, I would say this is a 10 out of 10 experience. However, there were times where I wish the communication could have been better and some of the deliverables could have been met at earlier times, i.e., the video that is being done on a Sunday. But I understand everybody had their own personal inquiries that they had to take care of. But overall, this was a great design process. I really love how the wheel came out. I really felt like it was a perfect example of wasted energy being harvested with the result of something happening that would provoke the user to keep spinning the wheel. I also think that we also met the design deliverable of it, surviving in PFT, as this is a very strong and durable design. Thank you for watching this presentation. Peace.